So welcome to the session. In our today's session, we are going to learn about performance tuning. See, whenever in the real-time project, right? Whenever we are going for any real-time project, so definitely we will be handling huge volume of data. So one thing is huge volume. The other one is the number of columns will be there. Okay, more number of columns, huge volume, and complex business logic. So in Informatica, just here we are using maximum 5 to 10 transformations, but in real time we'll be having a lot of transformation logic. That time it may take some time, okay, to implement logic for all the records. It will take some time. To avoid this kind of scenarios, we have to do the performance tuning. So if we are using, normally we are using these transformations in our Informatica, so definitely we will face performance issue. These transformations, like if you use aggregator, yeah, definitely we will face a lot of performance issue. So why? Because aggregator will consider all the record to aggregate the values. Okay, it will take all the records to aggregate the values, and the sorter, yeah, this is also, it will consider all the records, and rank transformation. So all these transformation, right? So every record it will compare and it will give you the results. So aggregation, lot of cache memory will be used, sorter, rank, join or lookup. So everything, the cache memory will be used. So that's what, if you are using these type of transformations, so definitely you'll be facing performance issue. Okay. So how do you know this session is running like a performance issue? So first of all, the session is long running. Okay, the session is running. So one thing is huge volume. You can check the throughput. If the throughput is very high, and also the huge volume, it is taking a lot of time, no issues. So let it be running, okay. But the volume is very less, but it's taking a lot of time to complete. And one is long running sessions. Or we might be going for the timeout issue. So timeout issue is nothing but, so whenever we are loading the data, fetching the data from source and target we are loading, so that time we might be getting the timeout issue. That's what timeout issue. Or session failed. Session might be failing due to the timeout issue, and CPU consumption is more. If you are getting this kind of issues, so definitely it's a performance issue. Either as a developer, we have to find out, or Informatica admin team, they will send you the mail saying that, okay, these sessions are getting a lot of time or taking a lot of CPU. So we are aborting this particular session, and then please take care. Please implement some performance tuning method. Okay. They will inform us. Another way, so if real-time project, if you have many jobs are running, okay, thousands of workflows sessions are running. If your customer is saying that, okay, if your manager is saying that, so take any top 5 sessions, top 10 sessions, and you implement the performance tuning method, something like a process improvement. Okay, process improvement. So ourselves proactively, we have to find which sessions it is taking a lot of time, and so what is the reason it is taking a lot of time, and we have to find out, okay, this is what it is taking a lot of time, and we have to fix the issue. How do I know that out of these many sessions, these sessions are taking a lot of time? Okay, we do have metadata repositories. Okay, so admin repositories in our system, we have created, right, repository in admin schema or info schema. The same way, in real time, the Informatica admin team, you can get the repository queries from them. So a lot of repository tables are there. Okay, metadata tables are there in Informatica. So we can go to the repository tables. Say for an example, whichever the table we are getting, like OPB. So this is the table starting with OPB is nothing but it's a repository tables. So OPB subject is nothing but, so these are all the metadata tables. If you look at here, select star from this table, it will give subject is nothing but folder name. See, whatever the folder which is available in our repository, all the folders it will be displaying here. Okay, you can query it. So this is the backend query. We can execute it, and then we can find how many folders are there. So what are the different folders, and when it has been created, all this you can able to see here. Okay, like this, we used to have a lot of tables. We used to have the OPB subject, task, instance run, and workflow run. So you can take this workflow run. So if you look at here, when the workflow has been executed, and that you can see here, select start from this one. If you look at here, So this is what you are saying. All the subject ID is nothing but the folder ID. Then workflow ID. So by using that workflow ID, you can find the workflow name, and each and every workflow will have the separate workflow ID. If you look at here, workflow IDs, what is the server ID, and when the start time, end time of this workflow, and where the workflow log has been created. Okay, then you can find where the workflow log has been created, and you can find different informations in this table. Same way we used to have a lot of tables here in our Informatica repository. I have given one repository query. This query will give you the top long running sessions. Okay, so each and every sessions, it will give you the session runtime. We can find, you can take top 10 or top 20 all the sessions. So if you look at here, subject name. So by combining multiple tables here, so you can take this queries in the net also. We can take it, no issues. Like from these table we have joined, and then see whatever the columns needed, so just we have taken that. So subject name is a folder name, workflow name, instance name, load date, session start time, session end time. Then you can find the duration of this session. Okay, so this is what each and every session's duration we can calculate. If your lead is saying that, okay, go and find top long running sessions, top 10 long running sessions, and try to implement performance tuning method for the test session. Okay, if they are giving you this particular task, then you need to talk with your Informatica admin team where the repository has been created, or give them this particular query. They will execute, or you can give the same query to a DBA. They will execute it, and then they will give you the result set. So from the result set, you can find whichever the session is taking longer time. You can take 5 sessions or 10 sessions. You can go to the subject, you can go to the folder. Okay, this is the folder, workflow, and instance, and you can get the session log for all these sessions. First of all, if I want to implement any performance tuning, definitely I have to analyze the session log. Okay, so definitely I need to analyze the session log. In order to analyze the session log, I need to know which session I have to analyze, right? So this is what you have to get the details. Okay, by using this below repository query, we can get the folder name, workflow name, session name, number of minutes the session has taken to complete. So everything we can able to find. Okay, after getting that, we have to get the session log either through monitor, or we have to get the session log from Unix server. Okay, so once you have taken the session log, in the session log you can find session load summary. So if the particular session is taking longer time to complete, so definitely you'll be having the 3 threads. This load summary, you'll be having the 3 threads. One is called reader thread, transformation thread, and writer thread. So reader thread, there will be idle time and busy percentage. So what is this idle time means? Idle time means, it is waiting for the data. So it's being idle. And then busy means, so it is using all the resource, 90% of the resources to read the data. So if the reader, we are getting more than 50, that means lot of resources it is using. Bottleneck, we'll say it's a bottleneck. We might be getting timeout based commit point in the target side, in our writer side. Why? Because here the source side, it is completely busy, occupied. Then target will be idle. So it will be idle. It is idle for 90%. Here busy for 90%, right? Here idle for 90%, only 10%, right? So this is what you'll be having the busy percentage. If you look at here, this is one sample session log. In any of the session log, if you are finding busy percentage is 100, that means there is a bottleneck. Where the bottleneck? Here, in the reader thread, there is a bottleneck. While reading, we are finding a lot of bottleneck issues. If you look at here, if the busy percentage is 100, then idle time will be 0. That means it is not idle. Completely it's busy. Okay. This is a writer thread. Writer thread, there is no busy percentage, 0 only. Okay. This is what total idle time. Why? Because so here completely occupied, right? So that's what we are finding the idle time. Okay. So this is what you will be finding in session log, you will be finding the bottleneck, either source side or transformation side or target side. This is called a bottleneck. So mostly in our real-time project where we will be finding the bottleneck, right, on the source side only. Okay, while reading the data, we might be getting the bottleneck. The second highest bottleneck in the target side. Okay, it depends on the scenario, which depends on the tables. So which table you are loading and from which table we are fetching, and databases also, and server capability also. It depends on these factors and the cache memory size and everything. It depends. First of all, if they are asking in interview, how do you find performance issues? So I'll be checking the session log where the bottleneck and finding that, okay, if the busy percentage is more than 70%, there is a bottleneck in the either in the source side or in the target side or in the transformation side. Okay, if it is a source side, if it is a source side bottleneck, so we have to analyze the source query, source DB, source table, everything we have to analyze it. Optimize the source qualifier query. So you can use some hints. If it is Oracle table, try to use some hints, or in the pre-SQL, post-SQL, you can write some collect stats. Before reading the data, you can do the collect stats on the source table and optimize the lookup queries if anything, and the indexes. So if the source table doesn't have indexes, in the pre-SQL you create index, in the post-SQL, we can drop the index and you can go for the partitioning. So these are all the techniques we will be using in the source side. Okay, we'll be using in the source side. Okay. Then target side. In the target, we'll be using the drop index. So if the index is there in the target side, then we have to drop the index, load the data, and after loading the data, you have to create the index. That we can use it in the pre-SQL, post-SQL. The next one is called partitioning. So partitioning is nothing but the parallel processing that we will see now, so that you will get clear idea. So these are all the methods we'll be using that to improve the performance. Okay, in the transformation side, if it is aggregator, then you can use sorted input or incremental aggregation. So that concept, incremental aggregation, I will tell you, but you know already what is meant by sorted input, right? So before rank transformation, you can place sorter. Before joiner, you can place the sorter. Before lookup, you can place the sorter. That's what you can improve the performance of these transformations, creating the lookup cache and everything. Okay. So you are using these methods, still you are not able to implement performance tuning. Okay, you are not able to increase the session runtime. Okay, so how to optimize them? We do have two different methods to implement the performance tuning. One method is called pushdown optimization. The other method is called partitioning. So definitely they'll be asking in interview. So what are the two different methods are there to implement the partitions? So one method is called pushdown optimization. The other method is called partitioning. What is pushdown optimization? The pushdown optimization or partitioning, these two methods is licensed properties. Okay, so separate license, you need to get it for these. In order to use these two methods, we have to have a separate license, the license property. So we will call it as pushdown optimization is nothing but PDO. So if you consider the pushdown optimization is nothing but converting the transformation logic into SQL query and pushing down to the source or to the target, either to the source or to the target, or you can push it to both. So that's what the pushdown optimization. If you look at here, so you can take, this is the left-hand side is source, left-hand side is source, right-hand side is the target. So here we have the target side. This is what the source side, source table. So this is the transformations. We do have transformations. Here we have the transformations. Here we have the transformations. A lot of transformations are there. And here we have the transformations. Okay. Here we have the transformations. And here this is the target. So left-hand side you have the source and right-hand side we have the target. Okay. So in between we have the transformation logic. See, all this will be taken care by Informatica. So the data is coming to the transformation source qualifier. After that, the data will be moving one transformation to another transformation, right? See, from one transformation to another transformation, the data is moving like this. And Informatica will take the data from source, that is source qualifier it is taking, right? Then cache memory, based on the logic, it will transfer the data and then it will load the data into target. So this target it will be loading. Okay, this is source side, this is target side. Okay, this transformation logic where it will be performed in Informatica level. Okay, so instead of doing this transformation into Informatica level, we can convert the transformation logic into SQL queries. So if it is expression or filter or aggregator or rank or anything, you convert that into SQL query. We are not going to convert. Informatica will convert it. Okay, convert this logic into SQL query and pushing down to the source side or target side. So if you look at here, so it traverses from source, and it will push. Okay, it will try to convert this transformation logic into SQL query. So as much as possible, it will traverse. It will convert. Informatica will convert it, this transformation logic into SQL query, and pushing down to the source side as the select statement. This is what push down optimization on the source side. Okay, the same way from the target side, it will traverse. Okay, the transformation logic tries to convert this transformation logic into SQL query and pushing down to the target side. So what is the query here? Insert. So it will convert insert or update. Okay, so either insert or update, so it will convert. This is what it will go for. So you can do both. Both means like it will try to push the logic from this side and this side. So remember, if I'm implementing pushdown optimization, then the source or target should be a table. It should not be a flat file. If source side is flat file, if it is a flat file, right? Say for an example, this is the source side is flat file. We assume that this is the flat file. So then I cannot implement pushdown optimization on the source side. If it is a target is flat file, then I cannot implement pushdown optimization on the target side, but still you can use it on the source side. So either one of the source or target, it should be a table, relational database table. So this is what we will implement. So where we will implement, right? So definitely we'll be having one options in the session level. Just you have to enable that. So we will not have here, but in real time we'll be having it. Okay. So if you look at here, source side pushdown optimization, target side pushdown optimization, then full pushdown optimization. So if it is a source side, it will convert into a select statement. Okay, select statement. The integration service generate the select statement as per the transformation logic. For each and every transformation, it can push it to the database. We are not going to write any SQL query. It will automatically write. Target side, yes, it will convert this SQL query like a insert, delete, update statements. This is what it will pushing down to the target side. So normally delete statement we will not use, insert or update we will use normally. You can go for both. So where it will be available, if you go to the any session, right? If you double click on the session, you can go to the properties. In the properties, you can find push down optimization. Okay, this is what the push down optimization. You can see here, you'll be having option called source, to a source, to target, to full, or you can pass this value as parameter. So you want to use a source or target side or full. It's based on the logic. Bottleneck, we can give the data in the runtime. Okay, this is what you'll be having it. Once you have selected, so this one, then if you go to the properties here, so you'll be seeing the mapping pushdown optimization. If you click on this, you'll be having view pushdown optimization. If you click on this, you can able to see the queries. We are not going to write any query. Informatica will write the queries. Okay. So this is what we have to implement the pushdown optimization methods. So just I have given the separate documents already. Please go through the document. You will get clear idea about pushdown optimization. If somebody asks in interview, so what is pushdown optimization? Have you implemented in your project? Yes, pushdown optimization is nothing but it's a converting business logic into a SQL queries and pushing down to the source or target or both. It's one of the performance improvement technique I have used in my project. Whenever I'm facing some issues on the source side or target side, as a trial and error method, I will implement pushdown automation. I will check that, okay, whether it is improving the runtime of the particular session. If it is increased, then I will use this pushdown automation. If not, I will go for the another method called partitioning. Normally, in most of the real-time project, we will go for partitioning. Whenever we are finding performance issue, so we'll go for partitioning. So partitioning also a licensed property. Here in our Informatica, we do have partition. We will do it practically. So partitioning is nothing but we can go to the Informatica, then we can implement some partitioning. So partitioning is nothing but it's a parallel processing. It is a parallel processing. So we do have, normally we have only one parallel thread. Like we have reader thread, read the data from integration service, we'll have the 3 threads, handles. So reader thread will read the data from source. Transformation thread will transform the data. Writer thread will write the data into a target. Okay, this is what we'll be having, the 3 different threads. Okay. Then we'll be having, if you are going to increase the number of thread, parallel processing in the sense we are increasing the number of thread. So instead of having 1 reader, we are going to make 3 readers. That means the same work, we are splitting the work to multiple persons, right? So if one person is taking 30 minutes to complete, if the same work given to three members, then it will be reduced to 10 minutes, right? The same way here also. Instead of 1 thread, we are going for parallel thread. How many number of thread? Here we are creating 3 threads, 3 parallel threads. First thread, it will run. Second thread, it will run parallelly. The third thread will run parallel. These 3 will run parallel. Simultaneously on the cycle based, it will run. So first reader thread will read the data. Then transformation thread, writer thread will wait for that. It will read. Then next instance, next cycle, next instance, the transformation thread will transform the data. At the same time, the reader thread will read the data, second data. Okay, this is what we'll go for the threads, number of threads, parallel processing. Sequential run. Okay, this is what the parallel processing. The same way, reader 2 will read the another data. Reader 3 will read the another data. So this is what number of thread. So first thing is we need to consider 3 things whenever we are going to implement partitioning. You can also explain in the interview. So whenever I'm going to implement the partitioning, I will consider 3 things. One is number of partitions. Number of partitions means number of thread. So here, for an example, I'm using 3. So this is the default. Normally, we'll go for 3 threads, parallel threads. You can go for 3 or 4 or 5 or 6 or 8 or 10 also. Normally, we used to go up to 10 different parallel processing. Okay, not more than 10. If you are going for more than 10, you need to get approval from your Informatica admin team. Why you are going for more than 10 parallel thread? Why? Because it will take a lot of resourcing. Okay, Informatica resource it will take. So that's what we should not go. Normally we'll go for 3 threads or 4 or 5. Okay, maximum. That's what we'll go with. Some cases, some project, they will go for even 8 or 10 also. It's based on the project and capability of the server. Okay, then we have the partition types. What types of partition we are going for and where the partition point is created. Number of transformation, if we have more number of transformation, where we are creating the partition point, that is also very important. Okay, number of partitions here, 3 threads. Partition type, we have different partition types. Look at here. So one is TB level partitions. So if the database table has partitioned, then Informatica, we have to tell that, okay, database level partition already done. Okay, not in Informatica, you have to do it on the database level. You have to do the partitioning on the database level, then you can do it on the Informatica level. And range partition. So if you have the data, definite range from 1 to 10, 10 to 20, 20 to 30. So like this, you have the definite range of data, some product IDs or department ID or anything, you know only these ranges you will get, then go for range partition. Normally, you will go for pass-through partitions. So this is for default partitioning is called pass-through partitions. Even one single partitions will have the pass-through partitions. Then we'll go for round robin, hash auto key, hash user key. So round robin is nothing but based on the thread availability, it will use that round robin fashion. Okay. Then you'll be having the hash auto key, hash user key. So this will use hash algorithm whenever you are using these kind of transformations, right? So you can go for hash auto key, hash user key. It's a hash algorithm. So each and every record will generate, Informatica will generate hash key, and based on that, we will be doing the partitioning. Okay, so now we'll go for, so one type of partition, we will see that pass-through partition. If somebody asks, so what is the default partition you will be using in your real-time project? You can tell them, I will go for pass-through partitions. Normally, we are doing a lot of pass-through partitions in the real-time project. Okay, so if you go here, I will open this. I will show you how the pass-through partitions will be takes place. Just I will take one table. So you can take anything. Just I'm taking the employees. Okay, I will take employees data here. So here, this is what the session. You can go here, mapping. You can see the partitions here. Or you can go to the partitions. How many partitions are there? We have the one partitions. Only one partitions is there. You can go to edit partition point. So this is the edit partition point. You cannot delete partition point now. Why? Because it's only one partition point is there. You cannot delete it. See, the repartition point must be specified at this transformation. We cannot delete even one partition point. Okay, that at least one partition point should be there. It is the pass-through partitions. Look at here. It's the pass-through partitions. Okay. Then you can go to the edit partition point. So I want to edit the partition point in 3 partitions, like 3 partitions or 4 or 5. So what is this partition type? So based on this scenario, how many partitions are there? We have 3 partitions. We have either you can go for pass-through or key range, or you can go for database partitioning. Here I'm going for the pass-through. If you know the ranges, then you can define the ranges also. So just click on OK. This is nothing but order of the partitions, which partitions we have to order. Then this is what I can go for 100%. Okay, this is nothing but window size. Okay, then you can go to the transformations. The 3 partitions will be there here. So in the SQL query or in the source filter. So we have to segregate the data based on the partition that we have to give. So how can I segregate the data? So here I'm going to use some common method. If I have a unique key, just I'm giving the unique key. Here employee ID is the unique key, right? So based on the unique key, I'm going to do the partitioning. So employee ID. So just I'm using the mod function. Mod of employee ID. Since I'm having 3 partitions, I can use 3. Mod of employee ID, 3. If it is equal to 0, then I can use this. Whatever the record, it's coming employee ID. We are dividing into 3. If you are getting remainder is 0, it will go into this partition. And equal to 1, it will go to this particular partition. Equal to 2, it will go to this partition. So its mod is nothing but it's a modulus function. I'm making that division of employee ID. See, for an example, employee ID is 100. If you are dividing by 3, so what is the remainder? It's a 1, right? So 1. So that 100 employee ID, it will go to this particular partition only. 2. So whichever the record is coming like employee ID 2 remainder, then it will go to this partition. Like this data will be moving from one partition to other partitions. So this is what we are going with the partitions. Okay. Then I'm going with target. No need to do any changes. Just you can give all the details. Then apply OK. If I'm going to run this, you can see this. Normally, this is what the partition will go for. Pass-through partitions. If you look at here, parallelly, it will run 3 threads. Okay, if you double click on this, normally we'll be finding that source and target statistic, right? Okay, surprise that why there is no node or apply node or anything. You can see the plus symbol here. If you click on the plus symbol, you can see the partitions, number of partitions. The 107 record is equally partitioned in multiple layers, right? So you can see So you may ask question here, the throughput is very less instead of high. So still we are having like 1 minute to 1 second to execute, right? So previously 107 record also 1 second. Now also 1 second, then what is the use? See, if you have huge volume of data, then this will increase. Okay, while starting, this is what the throughput. After that, it will get increased while session running. Okay, it will get increased automatically. So that is what it will be running. See, even lot of sessions we are doing performance improvement method in our real-time project. The session is taking a lot of time. Okay, based on the source data, target data, we will go for the partitions like this. Okay, so this is what one of the partition method. So you can go for the other method is called, so instead of pass through, we can go for some range partitions. So what is range partitions here? So I can go here. So instead of pass through, I can go for range partitions. Click on the partitions here, edit partitions. So instead of this pass through, can go for key range. I will delete it. You go for key range. I'll add the key range here. Apply. See here, if you are applying it, you will be having the key here, edit keys, right? So you can go for edit keys. Which key I want to go for? Employee ID or department ID or whatever it might be. So you can use some keys. So what is the key range you will be getting it? So employee ID, click on OK. Start range. So employee ID from 100, starting from 100, right? So you can take from 1 also. From 1 to 140. Okay. From 140 to 180. Okay. From 180 to, so you can use this 250. So like this, I'm just making that. We will check it, how the data is flowing. So apply. Okay. It should not get duplicated. So make sure that it should not get duplicated. Okay. So no need to mention this logic here. Just we have made it like here, no need to mention. So we can remove this. So just we have applied already, right? The ranges we have applied. No need to mention anything here. Okay. So this is what partitions you can apply, save it. Okay. Then run it. If you look at here, so this time we are running on the range partitions. We are giving some definite range, but make sure that in the future, it should not change. The range should not change. That's what you have to go for, the range partitions. In future, if the range is changing, go for pass-through partition. That's the best method. Okay, normally you go for best method. You can see here 40, 40 and 27. Okay, record has been 107 record has been split into multiple layers. So this is what you can find the range partitions. And if you have any other transformations, right? So for an example, I'm using sorter transformation. Sorter, as I told, if you are using any of this transformation, definitely you can go for the hash auto key, hash user key. If you double click on this, you can go to the mapping. You can see here you can see, and go to the partitions. You can implement the partition point. So partition point is nothing but, so here we have 1 and 2, right? We can add partition points here also. Just we can add it. So I want to add 3 partitions. So here I want to go for hash auto key. Hash auto key. Look at here, hash auto key. 3 partitions. Now here, what is the partitions? Pass-through partitions. Source side we have the pass-through partitions. In the transformation side we have hash auto key. So based on that, then you can go to the transformations. Here you can implement the source side. We can implement the same type of partitions. Like here I will go for mod function. So equal to 0. This one equal to 1. This one equal to 2. From the source, this is the partition point. From the source, it will take based on this one only. But after the source, the sorter transformation, it will change it based on the hash key. So this is what you can improve the performance of the sorter. Okay, this is what you can improve the performance of the sorter also. So you can see here, data might be getting changed after the source. After the source, the reading the data, right? After that, it will be changing. So here you can see here data is like here it is having that 35, 36, 36 only. But after the hash key generation, the target it is changing 29, but everything is same only. The number of record will be same. Okay, but here it is based on the hash key, the number of record passing through the partition will differ. It's based on the hash key algorithm. Okay, this is what hash auto key, hash user key you can go for. Okay, if they're asking, have you implemented any performance tuning method? You can tell them, yes, I have. First of all, what will you do? I will analyze the session log. I will find where is the bottleneck. And so if there is a bottleneck on the source side or target side, how will you identify? So there is a busy percentage, right? So busy percentage I will find, and then I will find where is the bottleneck. Based on that, I will go for the methods. If it is performance degradation on the transformation level, then I will go for transformation side, implement some performance tuning. If it is on the source side or target side, so based on the scenario what I have explained, you can explain them. So index creation, all this you can go for, or I can go for pushdown optimization or partitioning. Pushdown optimization is nothing but both pushdown optimization and partitioning is the license property. Whenever I'm finding some issues, so trial and error method, I will go for first pushdown optimization. It's a license one. It will not be available in all the project. Okay, some project they will not buy this pushdown optimization. Okay, some project only will buy it. It's based on the company. Okay, and here the partitioning is nothing but parallel processing. Parallel processing, we do have different partition types. We have to consider three things. One is number of partitions, partition type, partition point. Just how I have explained here, pass through partitions, range partition, hash auto key, so that you can explain them. So they will get convinced. Okay, this is what you have to explain the partitioning and performance improvement method and pushdown optimization in the real-time project and also in the interview. See, this is what you have to explain. So just we have seen, so that you have to explain them very clearly. This is what the partitioning is. They will just ask, what is partitioning? Have you done the partitioning? Performance tuning, what is metadata queries? So I will give you this document. Please go through the document, go through the video and practice it. So completely practices. This is what they will ask in interview. Whatever I have explained here, if you are explaining them, then they will not ask any questions. They will get convinced.